Hey, hey, Young.
Hi, Professor.
Okay, so let me show you where we have some problem on this. Let me show you see my screen now?
Yes.
Okay, good. So perhaps I need to go through the beginning because we actually stopped. Do I need to start from here?
Uh-huh.
Or I should, let me see. Let me see. Oh yeah, it doesn't. So we need to start from the beginning.
Yeah.
Okay. And run this. Run this. This one. Yeah.
Hongjie, do you want a coffee?
Okay.
Yeah.
Think right now we are again everything this I think everything works fine. One thing is here when we want to export the image as a GIF file. So let's do this one. Then do the texture. So we have 35 images.
Uh-huh.
Then we output. And here the image doesn't show. So we so we don't know what is the problem.
Can you
Yeah.
go a little bit upper? Like, yeah, this cell. I just want to see.
Is here okay? Yeah, I checked this with the original code. There's no difference.
Wait a second.
So yeah, so once you get here, there's no image, so that's why. Even though here shows the time, but image does not show. But we do in the beginning this doesn't work. Works very well, and then we change the composition, change all of other stuff. I can even redo this part. Oh, maybe I need to change this there. I believe that is the biggest thing to do with this.
I have it in your former order.
Ah,
It doesn't,
oh, really?
it doesn't work.
Yeah. So.
Oh, no.
Okay, so this is already working here. So, zoom in. So there's no problem. Everything. We did the senatorial, then work senatorial, then come to here. Again, for the to save. Then we do this. So 35 imaging. And this. Yeah. So y'all, do you have any idea why this doesn't have? Doesn't work?
I'm checking on my side as well. So yeah,
Okay,
I'm running
yeah.
it.
Okay, that's fine. Yeah, you check your side and once it works, let me know. Then you can actually share and see what is the difference.
Yeah, sure.
So we're waiting for a few minutes. Hello. Are you speaking?
Yeah.
Sí. Sí, lo vi, pero yo no pero parece que solamente pero no sé, era el no lo voy con la pero estamos una vez que lo ves ya estamos por otro lado. No lo he hecho yo. Siempre he trabajado por el campo. Mira, el parámetro que estaba buscando es el de danza, ¿verdad? Tiene otro nombre, pero también es para sí, claro. porque es HC. Con el mapa de lado.
Okay, how's that, Young? So maybe we can, you need some more time?
Yeah, I think so. Yeah.
Okay,
Actually,
so
on my
that's
side,
fine. We can start the last session. Then
Okay.
once you have fixed that, we can come back.
Okay.
Okay, good. Okay, so let's start with the last tutorial. So so I can. Okay, so we can start with this number 6. Yeah. Open altimetry and Google Earth Engine together. So we load the ICESAT-2 data with the open altimetry data, and then query Google Earth Engine for REST data, which is optical images. Then display the ICESAT-2 track on top of that. Then you will see lots of good information when you overlap them. Okay. So okay. So the original code is actually created by I don't know where these people are. I think it's from the ICESAT-2 hack week and modified by my student. So there's lots of people already put lots of work on this. So the good thing is it's free and it's open. Everybody can use. Okay. So let's start with install the library first. Every time that's what we do. Every time we do that. Okay. Then we need to install a new one, which is raster. Raster is another package. So we need to install this one. Success. And then we need to import a bunch of that. So originally in the past, we only needed the G map, the E, and the OS. Now we also need the JSON library, the Quest, the NumPy, pandas, the map, plot library, data type, also request from the repository. Okay, so let's do that. Now we do the initialization, authorization, all of this. You can see this code actually is very, very long, very complicated. So by the good thing, you don't need to worry anything, just run it. Then you come here, so then let's get the token. Okay. Continue. Check both. Continue. Then copy this. Go here. Here's 8. Yeah. That's good. Awesome stuff there. Yeah. Is successfully saved. Okay, so right now we want to use the OpenActivity. I think yesterday we already used the OpenActivity and is where you actually copy to get the API URL. So I showed you where to get that. So let's go to the get that. ICESAT-2 ATL06 land I type. So this is land I, so we will use that. And switch projection to Antarctica, they select the Gen 60. Okay, so there's lots of detail here. So then, he talked about the 06, 08. Okay, anyway, I say what the data we are going to check is this one. So where to get this one is if we go to, I think I mentioned it a little bit yesterday, come here, then click this one, then select the area region of interest. For example, if you want to come to somewhere, okay, just for example, this, then you click this one, select this one, then you view that. Then I think the code is actually on the ATL03 because we will use the ATL03 to begin with. So once you need to do that, then once you click this one, you will get the this one. So this is the API URL link. Okay, so then you will be able to select like here, select either the 3R or 3 left, or 2R or 2 left, and 1R, 1 left. Okay, so that's why we need to come to the function. And for example, right now I click this one, So this is copied to here. Then if we come back to here, and then this is where we copy paste the code to here. So I'm not going to replace this one, but I just show you what it looks like. So I copy paste to here. So you will see this is very similar like this one. Okay. Open altimeter ORG API ICESAT-2 all3. Okay. All3 data, the day, and all of this information. If you continue to the end, we'll have the JSON. Okay, we'll have the output format GSON. Okay, so it's that exactly the same. Of course, if you go to different place, the latitude and longitude will be different. Okay, so I'm not going to use this to replace the one is already here, but.
So which data, which URL are you using?
Yeah.
Because you can the elevation profile table will give you an URL. The photo heights give you different.
Yeah. Okay.
URL.
Yeah. Good question. This comes here.
There are many URLs that you can download.
Okay. So this is the first one. So if you once you come here, you will have the elevation, right?
Yes.
But then you click this one.
Okay.
Then the first API is the one we use. Yeah. So just use this one, and then you copy paste to here. So this is exactly the same. The only difference is the location difference from the example here. So I can go back. I go back to here. So then you need to select. So this one is you select the 2R or the 2L or whatever, the 1R or 1L. So it's depending on which one you actually look at here. So if you look at the interested use the 3 strong 3R or 3L, then you need to change this to 3R or 3L. Okay. So in this case, we use the 2R, 2L. Okay, this is the 2R. So let me delete this one because we don't need this here. Yeah. Okay. So this is a specific location is already put here, but we can actually I did that use the glacier of Jane he used and I successfully did that. So I can show you later. Right now, let's just make sure this works. Okay. Once you have here, then you can use the ICESAT-2 data connection. So right now, to create the ICESAT-2 data connection. So then you can see this will show you the data is from Open Altimetry API. This is the same link. Okay. The data is 2020 January 16. The tracker is 312. The bin is GL 2R. Yeah. So if you use like a 2L, this can be 2L. Then the latitude minimum, maximum, longitude minimum, maximum is automatically read from this this link. Okay. Then we run that. Okay. Then of course you can access this ICESAT-2 data from this open altimeter. Use the latitude, longitude, minimum, maximum, and like you already have here. So this is the minimum, maximum. We already know, but you can do the same thing. Use this method this way to access the data. Just give you the same information you already provided here, see here, and then the day, and so then this is the ICESAT-2 data to get the connection. Use the these parameters. Then you can open the information. Once you get this one, then you will see the same information. Open the API will get that information. So either way is fine. Either way is fine. So we can use this way to run that, and they will output this information, which is the same information you see here. Okay. So you have two ways. One way is directly go to here, go to the open altimetry to find the link. Another way is you know the exact location, you know which one you want to do. Just write like this, then the open altimetry will get the information, get the data. Okay. So once we have that, then we can really request the data. So this time we'll request 3 data sets. One is the O3, one is the O6, one is the O8. So O3 is the fountain, O6 is land ice, and O8 is the vegetation, is the land elevation and vegetation canopy. Okay, O8. I think this. I remember we talked about O3 is a low data 11 meet footprint, natural longitude with elevation. O6 is already 100 meter aggregated, and O6, O8, I think, the same. I think O6 is 40 meter. Land ice is 40 meter aggregation. And the O8 is land elevation is 100 meters. So we pass this data. Then here it shows the information. So then the similar information we see that before. So give you the track number, the beam we use, and the latitude, longitude, minimum, maximum, and this will give you examples of the data, what the data looks like. So all 3 data, you have the ID from 0, 1, 2, all the way to as big as I think as big as 46,115. Okay, then you have the latitude, you have the longitude, you have the H, which is the elevation on top of ellipse soil. Then you have the confidential level. So this is the confidential level tell you this is low, and this is the very high confidential. Okay, so the same information you saw here, the same information you saw here for individual track. So it's low or is low confidential, medium confidential, or high confidential. So this one is a figure, is a plot. Here is individual photon numbers. The information is requested here. Then next one is the O6. Okay, the O6 you have the very similar, but like I said, this is 40 meters aggregated. Okay, 0, 1, 2, 3. So the maximum instead of 46, 11, 115, here is only 555 because they already aggregate lots of functions into 40 meter average. Okay, so latitude, longitude, then height. So here is the height. So you don't have this computation level anymore. Okay, if we look at this, the O8. The O8 is we have the ID, and you see this number is even smaller because the O8 is 100 meters aggregated. So So the maximum in this case is only 118. Okay. Then you have latitude, longitude, and height, and also canopy. If it's on top of the vegetation, then we'll give you the canopy height. If it's on top of the land, will be the land height. Then the canopy height will be NAA, the low data. Okay. So depending on if this point is on the land or is on the canopy. Okay. Then we have some others. I think that's all, right?
So the coordinates you're showing there, are they exact number of decimals, or is it just for visualization purpose? Do we have more? Because if I compare that to like 70 degrees, 15, 1.5,
Yeah.
15 plus minus 50. But the distance between the paths is about 11. So I guess you open that in a CSV format, it's gonna have more decimals, right?
Oh, okay, that could be. So if more than I think if more than 5 or 6 decimal number is not.
Yeah, it's not shown.
Yeah. So only show you the 6 numbers, I think, probably. Yeah. Okay. Then plot. So voila, we is going to plot the 03, 06, 08 data together. So if we run this one, yeah. So this is the data you will see. You have the 03, which is all of the functions, the dots, all of the functions. Okay. Then 06, which is the land ice, and then the 08 is the land height, land ice height, and this land height. Okay. So then this one you see loss of this is probably the lake. Okay, this is a lake, and then this is the surface of the lake. This is the bottom of the lake. So you see lots of fountain also coming from the bottom of the lake. That's why. So you can see the lake depths up to like 10 meters, So this is a very good example. You can actually pay the return from the bottom of the lake. But not literally every lake we can get this same information. So we try for the lake in these glaciers, we don't see that clear boundary bottom. So it maybe is there's lots of sediments in the lake, so the light cannot get through to the bottom. So, but this lake is because this is in the Antarctica, so it's very clean. There's no sediments, so that's why this can go to the deep. I think that's one of the reasons we say to the deep. Okay, so then this one is to another way of plot the same data or a big large area, plot it into a large area. So the same link and plot again. Use the title direct mapping. Okay, so here in the top you have a title. Some ICESAT-2 data are found on the open imagery. So it's where this title is coming from. Here, yeah. So there's title, there's the x-axis, y-axis So you can see the x-axis latitude, y-axis elevation in meter, and the title, and all of this information will be automatically added. So this is the center of this track, of this part, and the ICESAT-2 track information, track 312-2R on 2020 January 16. So all of this information is not here. So ICESAT-2 track number, day, latitude, longitude, and format. Okay, so you can see this information is already here. Also have rating. Where to put the rating? Lower right. So the rating is in the lower right, which is here. Okay. So this is a very simple language. You basically what you write is what you see. Okay. In the rating, you include the label ATR06, ATR08, ATR03, the color all in the color, in black for 03, in yellow for 08, in green in 06. So this is the color black. Here it didn't show the color, didn't say anything about color, but this is the style, the dash. Interesting, yeah, because this one didn't say the color. This one has a color equal to black. Then this is a plot of the same thing, but a little bit large, little bit wide. Okay, so this information will be requested for the Google Earth engine to find the optical image. Okay, so right now this image is used to get the latitude, longitude, minimum, maximum, then return. So return the distance. Okay, this one will be return the distance between the profile. Okay, return the distance from here to here, the profile, how long this distance. Okay. So it tell you the distance after this calculation, the distance will be 11.7 kilometer. 11.7 kilometer. Okay, so let's run this. I think we finish that part. And,
is that the same URL?
It's
the same URL.
The same URL, the same URL, yeah, exactly the same URL. Okay, run that. Yeah, okay, then one now is calculate the distance, the distance of the profile. And we show you the distance is the ground track is about 11.57 kilometers. Okay, so they show the ground track on the map. So this is going to show the ICESAT-2 ground track on the map. So that's putting the basic map. So now you put the ground track onto the map. And add the lane and show that. Take it here, yeah. So this is original. This is actually the base map for the Antarctica, but this is the track. So the base map is actually not very well the location accuracy is not very good, because this track is actually reality is passed through this lake. absolutely safe. But this is a base map, old base map accuracy is not that good. Okay. Then so right now you can get the optical image from this location. So in this, let me see. Okay, yeah, we can continue this. So so we can get the Landsat image. In this case, the same thing to go to the Landsat collection. Okay, so we talked about this morning. Then we get the image collection, Landsat. So we call the collection name 1. Then for the interest, we feel the center of latitude longitude, which is the profile center. Okay, then you will find there's totally 527 images in this location. In this location, so the central longitude latitude is the central longitude latitude. Central latitude longitude of this track, of this track. So it's somewhere here, central latitude longitude of this track. So they use this one to get the Landsat collection, which is 527 images. So here is to search for image for a period of the time, which is a 15 days before and after the ICESAT-2 image was connected. The actual ICESAT-2 data was connected. Okay, so we use the day path, which is 15 days before and after. Okay, so we'll search January 1st to January 31st. So our image is January 6th, January 13th, right? Let me see. Our image is our ICESAT-2 data. Yeah, January 16th. So ICESAT-2 data January 16th. So then 16 day or 15 day before, 15 day after, which is 15 day, we use the 15 day. So then will be January 1st to January 31st. You can change this to whatever you want to see. Okay, so right now we use the 15. Then how many images? Find there are 10 images in this 1 month. Okay, so if we want to change this to, for example, 30 days before and 30 days after, see how many images. Okay, so we'll start from December 17 to February 15. So then we will see how many images in this period. Okay, so this one, this all 17 images. Okay, so you see there's 17 images. So well, I'll go back to the original 15. Okay. Do it again. Run again. Voila, is we collect the image and also sort, collection, sort. Okay, so this is there's a collection sort function tool system time start from the beginning to the end. Okay, so totally 10 images. Okay, so then also sort the data. Use print the property and the ID. Okay, so that is 10 image start from January 5th. January 5th have 2 images. Okay, then January 7th 1 image, January 12th 1 image, January 14th 1 image, 21st 2 images, 23 1 image, 28 1 image, and January 30 1 image. Okay, so this is the 10 image with the ID, and then this is print the first image. I think this print the first ID. Okay, so this will be the first January 5th, the first ID, and then we'll put this track on the first image. Okay, so then use the composition band 4, band 3, band 2, which is a 2-color image. Okay, 2-color image, and then we will have the ground track on top of it. You see, this is the image, Lancet image, and with our ICESAT-2 track. So right now you can see the ICESAT-2 track is from open altimetry. Then the Lancet is from the Google Earth engine. Google Earth engine. Okay. Yeah.
When you open the ICESAT-2 data using the link, does the data enters get uploaded into your cloud, or it's just calling?
Coding. Yes. Yeah, just coding from the ATL. It's not downloaded to my
Very useful.
Yeah. Yeah. Okay, so let's continue. So this is make GE map. So here is actually looking for more data, which is a lot just include the Lancet and also the Sentinel-2 data. Okay, so you use this function. This function will get more data in this 15 days before and after, and we'll get more data either Lancet or Sentinel. So this is the track on top of the first image. Okay, on top of the first image, which there's lots of cloud. Okay, so interesting to see. Let's look. Let's get a little bit of time here. Really interesting. We can look at the individual images. So I need to make it a little bit smaller. So click this tool. Okay, so click this this legend. You will see all of the image. The first 2 is Lancet, so it's 11 days before the January 1st or January 16th, because ICESAT-2 is January 16th. So right now I think we can do. Yeah. Okay. So then this is the 11th day before. There's lots of cloud. Okay. So then this one is a larger 11 days before. There's also lots of cloud. This one is 10 days before, which is the Sentinel-2. You can see the Sentinel-2 has a higher resolution than the Lancet. This is the larger one, so you can see this this actually looks very nice, why not? But we will see a very good image. This one is not good. This one is also lots of cloud. And this one is really good. Okay. So this one is only 2 days before the ICESAT-2. So you can see this lake, and this is the surface melting, and also the river, the melting from other place, and also coming to this lake. Okay, and 7 day, the seventh, which is exactly the other one. So really, you only see a few days. You have very good overlap, very good clear sky. This is this one. Yeah, this one is also not good. This one is not good. This one is also not good. Yeah, this one is good for some part. This one is the same day. Yeah, so really the best image for this case is this one. Okay, I need to close this one. Yeah, I think this is the best image. So the number 6. If we go back, look at the number 6. Look at the ID of this image. Number 6. Okay, so that is this one. Okay, so this is the T2 alpha 165 110 114. Okay, so this is if you copy this, then go to bottom. You can use this one to replace this one. Yeah, I think this is the example here is use the other day use the sentinel number. Yeah, we can replace this one with the base image, which is the Landsat. Okay, and then to overlap with the ICESAT-2. You see, so right now you can see the base Landsat image is overlaid by this sentinel. Well, I'm sorry, ICESAT-2. So this is the left, which is the 2 image. Right is ICESAT-2 profile. Okay, so very nicely shown here. Okay, so I actually did this for Jane's glacier, so I can go to open that. Let me go to the copy of that one, because I saved to another. Which is number 6. Probably number 6, which is okay, this is the one. So this is the one actually we worked 2 days ago. So see. So Jane, this is your data. So this is the first one. the enticing, okay. This is the early top of this which one? So we actually have few images. So which one is the best? Oh, I just show one of them, not the. So one of them on top of this pass through, and so this is one of the images. I think it's the sentinel one, sentinel 2 image, and then this is the profile. So which one is the one I use? Yeah, I used this one. Yeah, so Sentinel 2, March 27. March 27. Okay, Sentinel 2, March 27. Which one? Sentinel March 27. This one. Okay. So there's two. One is 18, one is 19. Which one I use? I use the 18. Okay, there's two sentinel here. Yeah, it works. So the scale of this scale is much smaller. It's only 2 kilometers. Yeah. Okay. So I think it's really possible for you to do it by yourself, to change the code a little bit, and for your area of study. Okay. Is anybody able to get to this part? Huh? Oh, just what do you do? Oh, good. That's good. Yeah. How about you? Huh? Oh. Oh yeah, you have that. So this is another mix. Okay. So it is still that okay? There's somewhere. I can say that my copy of them. Yeah, the audio few years to change. She was a long track. Oh, yeah. Okay. So yeah, this one, yeah, this one I can send you the link. You are in Zoom? Or you are in the Zoom? Oh, you're not in the Zoom. I can send you later when you send me. Yeah. So the only a few places I changed is of course this one, yeah, from the beginning, yeah, this one, because we this is the 3L. That's the only one we have the 3L for that day, and Yeah, March 26th. Then I was saying, rather than. So here, yeah, we don't see the bottom, maybe a little bit here. Is a lot of that outstanding like from this example. Okay, so we can continue to do another example. Here show asymmetry. Okay, here's asymmetry. So so this is from the. Of course, you need to define where you want to get this, and then the center, and also that copy that APL link to here. In this case, is 1R. Okay, so we click this one, and then get the data, which is so this is good. So you can get both Landsat center data for yeah, for positive negative 25 day of ICESAT overpassing. Okay, so then this is the this is the for this area. So if we want to see where this area it is, we just zoom, make it smaller, make it a small way to. Okay, so this is the this. Now me, now me here. Okay, then also we can look at where the image, which image is the best. So our things. We need to click this one. Look at the legend. Okay, so this is the individual images. They are here. Okay, so this is the first image, which is 20 days before. This is the 22 days before, 17 days before. I think this is a very good image. This is a good image. This is not very good. This is a lot very good. Also top. This is good for this area at least. Yeah, this is also good. What are you? This is lost cloud. Cloud. Yeah, this is a good image. This is a good one. Oh, so this area actually have lots of good images. So which one we actually selected? I think this is the one. The 70RRG December 13, December 13, December 13 PRRG. Okay, this one, which is number 7. Okay, number 7. We can check the number 7 here, which is this one. You see the power by this. I'm checking this. Yeah, number 7 is very good, very good. So they in here, number 7 is as the background. Okay, number 7 is yeah. So number 7 as the background, ICESAT-2 overpass, and this is the ICESAT-2 profile. So you can see this is a very clear bottom, very clear bottom. This is the coast. is Bahamas, right? Somewhere Bahamas. Shallow water. Yeah, shallow water. Yeah. So it's you see up to even 20 meters, right? From lecture 30 to lecture 50. Yeah. So this is the bottom is very clear. So that's most people actually use this to very, very good, very good. So this probably is an island, a small island. I think it's somewhere here. There is a peak here, which is here. Then the ocean. Okay. So half dome. This is another example here. So the same thing you get that information. Actually, this is all 6 data. You see, all 6 data. All 6 and GT2L and then continue. So the basically, I think we know is ICESAT-2 image and O3, O6, O8 data also download and then plot to here. So this is the profile. ICESAT-2 profile. So half dome, actually, I don't know where is half dome. So 17. Huh? The 17. The latitude is 37. Latitude 37. 47 somewhere. California. Anyway, there's a lot of ice shelf reef. Okay, ice shelf reef. So this is used the 3R. Okay. Then the image is Landsat. Then oh, this is a Shackleton ice shelf. Oh, this is very nice. See, yeah, very nice. So you have this lots of surface melting, but here there's a big crack. They call the reef. Big reef. So there's a photon actually returned from the bottom of the crack of the reef. There's lots of surface melting. You see, surface melting. Yeah, I think this one, this one, then this one, the reef here, and this one is this one, I think, and then this one is this one. Okay, so you can see very good overlap, very good information. Let's see what else. Oh, Melt Lake in Greenland. So it's a lot of example. Melt Lake in Greenland. So this actually uses the O8. So you are not necessarily just use the O3. You can use the O3, O6, O7, but eventually we get all of the data O3, O6, O7. So you can see this is the use of O8 data, and then they also tell you use the 3L. So I think it's easy to use the all three because you can know which one is this. But eventually, no matter what you use, the 3 data set will be requested. Yeah, all 3, all 6, all 8 will all requested, and will be shown here. You see, this is in the Greenland, the surface melting, and you see this pattern is not very clear, but at least is very clear to here, and very clear to here. Okay, here I think I more or less can figure out this is the shape. This is the shape of the surface melting. So if this is the pattern, which is 300 to 330, yeah, it's like 20 to 30 meters. Yes. Okay. Oh, I cover the lake or I shell. So this one is all 6, use all 6, and also the 3R, latitude, longitude, minimum, maximum. So this is the ice. This is the Antarctica. Okay. So then you have a good lens at the evening. Request both so 3 data set, or 3, or 6, or 8. And this is the map. Oh, very nice, very nice. Okay. I think this is coming from here, right? Coming from here, which is here. I think this is the bottom. This bottom is this. They go up. Is that right? Well, I think this one is not clear direction. Or we can see the direction. Same on one. 713, 25, 26. Okay, 25, 26. This is 6 or 0. Yeah, it's not simply. Okay, so practice your own example. So you can do your own example to get your data and use this one and to find the overlap and then do a map like this. Okay, so that's all. I think this is yeah, this is on the Canyon Lake. Oh, this is the example Canyon Lake, very close to San Antonio. Yeah, so we can run this one. This one. This get data. Okay. So then let's check which day is the best data. This day is not very good. This is not good. This one is okay. Okay. All 3 is good. All 4 are good. Yeah, this one is okay. There are some of the early ones. Yeah, all 3 is the best, I think. All 3. Let's go see what is all 3. All 3 is this is Sentinel-2. Yes. This is the same one. I used here. 14, 39, 14. Yeah. Oh, so it's 37. Okay. Yeah. So I can replace this one. Okay. And this. Yeah. So this is our power of this all three. And finally, so I think you can see the bottom, a kind of bottom 20 meter. Yeah, 20 meter. It's not that distinguished, but I would more or less say this is correct. 20, about 10 to 15 meter water depth. They do the two edge to the edge. So this is 3 kilometers. Here. Yeah, I think we ran through all the code. Can you do it? Yeah. You want, if you want to do a lot of tests, yeah, you need to either find the center or find the square, or you go to the open altimetry to find the exact track. Then you copy that link here. Yeah. How's that? Yeah. Okay. How do you? Yeah. So you go to the altimetry, yeah. Find the speed. Usually what we do is this one select. Yeah. Go to see over the. There's more data. Yeah. Maybe go to this lake. This lake or you add. Go down a little bit. Yeah, either one is fine. Looks like this one is good. Yeah. So if this one is good, not this one. Yeah. So now this is the API. Yeah. It's go to the yeah. Yeah. So let's go back here to see which track we want. 3. Okay. Yeah. Okay. It's 3. Yeah. Okay. 1 there. How about you? Yeah, okay. Yeah. Okay. Yeah, this looks like a.
What is the data?
See it going down. This is the. Yeah, this is the solution. Is I think in all. Is all three. Is all three. You will see the you will see the data from the all three. Even though all three not show here, but in the right click in that figure you show there. The one we just copied that. Yeah, yeah. So if you see the yeah. Yeah, here you don't see any presumption stuff. Yeah, so this means this there. Yeah, yeah. Oh, the example is videos. Yeah, I think the trail was reviewed. But the data really should come from those. If you don't have data, you just need to change the data. Yeah. Okay, check the most.
Yeah.
Yeah, it's not that clear. So sometimes it cannot get the bottom. Yeah, sometimes, yeah. Sometimes don't get it. Yeah, if the water is really lots of sediments, lots of contamination there, you will not get the assumption. Okay, I want to see if Yang actually fix that problem. Yang?
Actually, I tried it, but I think the Gmap module has some problem in that function, like download a video, because yeah, I check all of the actually the image collection is correct, and all of the input parameters is correct. So I think that function has some problem. So
Okay.
but if you want to download the GIF file, Actually, if you run that time series in the G map, there is a kind of link. You can download the GIF file. So if
Yeah.
you want to download that file, then you can just directly use that link.
Okay, so use that the image, you can make your own video.
Yeah.
Yeah, so even though the Google's engine, maybe that function doesn't work, but you can download the data and make your own video.
Yeah.
Okay, good. Thank you, Yang. I think we finished all of the code. It works very well.
Mhm.
Yeah, no problem. That's the only problem I think you also answered. So looks good. Okay, thank you.
Yeah, great. Thank you.
Okay, yeah. So yeah, so one of the problems we really find is not the code does not have any problems. Is probably Google's engine the video producing as a whole not show that. But if you download the individual GIF images, you can make it your own animation video. Yeah. Oh, you have a calendar. No. Yes. We use that production. But there was a different one, C01, T2. Yeah, T2. The T2, T1. Yeah. That one, I couldn't find T1. Oh. So I started to remember okay. That one. T1 was. Yeah. T1 was T2. So that one gave me that. So you can whatever things you did. So basically, it's going to be so that's the nature. Normally, the nature is more like restricted to so this area is less. See, this is the whole area. So the nature is that. Yeah, the whole this part of the nature. So the stop is good. It should be on this zone. Right? Yeah. The last one. Yeah. But at that time, we said, yeah, at that time there was and so the bridge should be. Yeah. Okay. Okay. So so we figure out what's going on. Those is a slow increase. How many? What is what is the five? Yeah. Yeah. So it's like 20 feet. Yeah. Yeah, yeah. So I say this is just yeah, it's the same. So if you look at this, it is like 200 or 300 feet, right? That's impossible for the snow. And that's no. Yeah. So this is probably the blowing snow or the actually something in the air. Blowing snow. Blowing snow is 200 meters. No, impossible. And this was actually this should be clearly now, the other thing is that I don't understand why. Okay,
This is,
39,
so this is not, this is not.
yes.
So
So that means loss, that is loss. Yeah, this is loss. Yeah, okay. So this is stop.
And it's going.
Yeah.
So the whole thing, just,
Maybe this part has loss. That's possible because the wind blowing the eye so yeah, possible cloud. So that's what you can see. Yeah. Yeah, and all the same way we show you can use Landsat or ICESAT-2 image. So you know you just go, go down to see if you have the same day or the day before you know. Yeah. Okay, 0 day. Yeah. Okay, yeah. So this is the 0 day. Looks like you have something in this part. Yeah. So that's why you have. That could be cloud in this, yeah, from this image looks like the cloud. Let's look at the other day. So, yeah,
But,
yeah, so you already,
so
you
what
already get all of this, yeah,
maybe what I should have done is to check first.
yeah.
Yeah, but no, but this is very, actually.
Or the region.
Maybe I should check first whether there are clouds.
Yeah, for example, yeah, so today there's lots of clouds.
Is this actually?
Is that cloud? Yeah, this is all cloud.
So when it's clouded, then they should.
Yeah. But if there's no cloud, if there's cloud, why you have data? If cloud, you should not have any data. Yeah, that's.
So the result will never get. So this one should be that, so that's that. What am I showing you? What am I showing you? Okay,
Oh,
want to be the point.
the ICESAT-2 point.
Yeah.
Yeah, so. You don't have this.
Wow. See, if don't do that, I take it. 17 or 7.
Yeah, but it's cloud. It's cloud is.
No, it's not. Look.
Oh, it's not. Yeah, this should have data. But
I mean, it tells me that it's there, but it's not giving me the point.
18, I think that's the data. 18, I think.
Why that? I'm not.
Yeah. This is data.
How many?
Oh, maybe, yeah, I leave the way because cloudy. Yeah, the 18 have data.
Yeah, but that's the one that I was taking.
Yeah.
Okay.
Yeah. Yeah.
And. No problem.
Yeah.
On the.
Now, yeah, you know, now.
Yeah, that's horrible. So funny, there is data from the clouds and no data.
If it's M cloud, C cloud is okay. But also, the image is just one that time. But maybe the data is gathered before the cloud will be or after the cloud.
Yeah.
They are not exactly same.
Yeah.
So they just, yeah, this is just a reference. You cannot use that conservative.
Right, so that's why I basically what I see here, so we, this network, yeah, it shouldn't be those.
Yeah, so this is the cloud or is growing slow. But this is for sure.
So that, this is absolutely.
Yeah. Yeah. Good. So you need a student to look at this stuff. You don't have the time
No.
to look at all of this stuff.
I need to know how it's done before I can figure
Yeah.
it out.
But I think you already got it. It's good. Yeah, you can request data, you can sensor data, laser data. Yeah.
So Hongjie, I missed one part. What did happened with it? Again.
Oh, yeah. So he said he tried that, it doesn't, the nothing wrong, the code is because maybe the Google engine, the producing the video, the function has some problem on it.
Okay.
So,
Yeah, it is, it doesn't work, didn't work for him.
yeah, it works before. Then, but the image, individual piece image is already stored in the link.
Yeah.
So you can download that image, you can make it your own video. And still do that. Yeah. Yeah, this is a very good example of potentially of wrong brilliance. Because yeah, if the maybe it's coming from that, from the laws. That's what it's.
Yeah. See what I mean?
So if Mr. I'll ask, you guys have geology, geoscience, math degree.
We don't have a master yet, but history.
Oh, maybe for geology, you have a geoscience bachelor degree.
Yes, geometry.
Geology.
Geometry bachelor.
Bachelor.
It's more than that, normal master.
Yeah,
It's 6 years.
Yeah.
It's almost equivalent to a master. It's equivalent to a master degree in Europe.
Oh,
Maybe in the US it's a bit less than a master because some people do
okay.
it depends on where you
So you are going to have a geoscience PhD degree?
Oh, they do that.
We do have.
It's
Oh,
we do have science.
Oh,
PhD program in geological science.
oh,
You have a master's in. No, that's yeah. Yeah. But soon, I guess, next few years, we should have a master's degree. This is just, we just updated the curriculum.
So was it? Is there a problem with that?
Yeah, it doesn't show now.
Yeah.
Yeah.
Okay.
So I really have to push it.
Still zero. Which area? Is the one we check actively? Oh, I think I find images. Come here. Come here. Sure. Let me copy this to you.
Did you use Copernicus? Or did you use that?
Let me see. Which one? Yeah, this one. I love this. So, okay.
What's the last thing? Yeah, get to the where you have the Lancet image. Okay.
The bottom. Yeah. Yeah, I was using this five wide collection is not the yeah, that's what I was.
They even wonder if the Lancet image is the same.
Yeah, that's a good question. So, but this looks like the loss of you see, line day before. This is mostly actually the sentiment. Sentiment. Only one is it.
Here, nature is that in this direction. That's in this direction.
Yeah. Okay. It's let me yeah, let me okay. Let me copy this email to you. This there you can open there. Okay. Okay, yeah. You cannot get lucky.